This experiment is all about the moments at work, and we're going to have a look at, in this experiment, the effect of the force on the turning moment. Now, what we're going to do for this setup is we're going to have a ruler, and this ruler has a hole in it, and what we're going to do is place the ruler through here, and what we can then do is support this ruler with a Newton meter, a spring balance. So let's set up what we've got, and I'm going to take a spring balance or Newton meter, and we can put this at an appropriate distance, and the basic setup we've got is like this. So we're going to place some weights on the ruler, and as we pull down we should be able to record the force applied, and as we move this string further along or increase the weights, we can see what happens. Before we start this experiment, it's necessary to get it set up properly, and what I get my students to do is to have a little investigation about what's going to happen before we start the experiment. So let's have a look at that. It wants to go down probably ½ a centimetre. Down. Yeah, because this is it. That looks about right. So that one end goes down, the other end goes up. Okay, now what we're going to try is we're going to put the weights on at different distances. So at the moment your pulley, sorry, not the pulley, the Newton meter is at 77, and this we're going to make at 10 centimetres away from it, and we do notice that you have to hold your hand down there because there's a slight technical hitch here. I would use this. This one's got quite a lot of weight in it. It's going to stop it moving quite well. Right, and now we can measure what the force on the Newton meter is, and then we can move this along, and we could move it along perhaps to 57, and we can now see the Newton meter's got even more force on it, and then we can move it along again to the next distance. Let's go for another 10 centimetres. And we can record what the Newton meter's got on it now. Which is?
It's gone to about 4.5.
Now, do you think we need a better Newton meter? I gave you a selection of Newton meters and you wanted a 20. Yeah. Do you think a 10 might be better?
Yeah, I think a 10 would be more appropriate.
Alright, so let's replace this with a 10 and see what happens. Now the equipment is set up, what we then need to do with this is investigate what's happening. Once the student knows what's happening, then we can do the experiment proper. Let's have a look at investigating the experiment. So if we've got this on 76,
I don't know,
78, sorry, 78, so where do you want to go for 5 centimetres for, actually it's not, it's 78.5,
yes,
isn't it?
So we'll do 73.5.
Okay, so make it at 73.5. And let's record I'm not sure that ruler was horizontal really to start with, was it?
Do you want me to double check?
So is it?
Seems to be dipping after a bit.
Okay, so bring that far end down a little bit.
This one?
Not the bottom one. So if you bring it down, the ruler will go up.
Okay.
And I'm going to take the weight off here.
Cool.
Because you're going to try and get it level. Now there is an easy way of trying to get it level. How would you try and get it level?
Through the distance of these.
How about using a tool to try and get it level? What tool would you use to try and get it level?
The meter.
A spirit level.
Oh.
Come across a spirit level?
No.
Now the preliminary investigation is complete. Now we can do the experiment proper and we can record the results. Let's have a look at this. Push that out of the way. Right, let's see what we're going to do. And I've got the camera set up. Right, so we've got this approximately level. Mm-hmm. Let's now set this at where it wants to be to get it vertical. 77's about vertical. So we're going to measure now at about every 5 centimetres and we're going to see what happens. So what's the force when this is not doing anything? It's just the force on the ruler.
2.4 newtons.
So we can take this and we can say at the moment the weight at 0 is going to be 2.4 newtons. Right, let's now have at 5 centimetres a 100 gram weight and let's see what it's going to do.
Okay.
And so that's at 72, 5 centimetres across, and what's the force on
3.8 newtons.
3.8 newtons, okay. Let's try it at 10 centimetres, which is going to now be 67.
It's 4 newtons.
Exactly 4 newtons, okay. Yep. Right, let's try it at 62.
Um, 4.1.
So this is at 15 centimetres, this is 4.1 newtons.
So it seems to be slowing down.
Okay, let's try at 57, which is another 5 centimetres on, which is now 20 centimetres.
Oh, it's just gone to 4.3.
4.3 newtons, okay. Let's try at 52, which is 25 centimetres.
Okay. .6 newtons.
4.6 newtons, and we'll try one more at 30 centimetres and see what happens there. So that's going to be 47.
And it's 5 newtons.
So that is going to be 5 newtons. Whoops. I tried to do that nice and easy, didn't work. Right, okay, so now we're going to try 5 newtons. Do you want to try one more?
Sure.
Right, 35 centimetres, so that's going to be at 42.
Just getting close to the table.
It is.
It's 5.2.
5.2 newtons. I think the next one would definitely have to be our last. I reckon it's going to hit the ground, so we'll try it.
Okay.
Try at 37 then.
That's 40 centimetres.
And that weight really is just about touching. There we are. 40 centimetres.
That's 5.3.
Only 5.3 newtons. Okay.
It didn't go down that much.
What do we take away from this experiment? Well, this is only the first of 2 experiments. So what we now need to do is investigate what happens if we keep the distance the same but change the mass. So let's go and have a look at another video and we'll see what happens there. See you then.